I didn't have the biggest gap on the ball, but hitting the low fade shot, like not a straight shot, but
Hello, hello. Welcome everybody to another month of ClearCalcs Design Basics. I'm having a little technical difficulties on my end, so I'm just gonna mute myself for a second and I'll be right back. All right, apologies, everybody. I'm just gonna go ahead and continue with my camera off just because my camera is being weird. So like I mentioned, welcome to another month of structural design basics here at ClearCalcs. I'm gonna try to power through the technical difficulties here. If for some reason we can't get through, then we'll definitely make sure to send out a recording to everybody who has attended today. As you guys all know, today is all about designing beams in the real world. And thank you, Jason, and Brian, and Martin for sending through some comments there in the chat. All right, I skipped one. Most important one, about ClearCalcs.com. So as many of you guys know, ClearCalcs is a cloud-based structural calculation software aiming to be more accurate, eliminate wasted time, and of course, we want to be available everywhere. More accurate, we want to do that by using our FEA analysis, and then also, as I hope most of you have seen, through our transparency. So like I mentioned in the last webinar, so continued partnerships and agreements with the codes and standards bodies to make sure we're as transparent as possible, to make sure you're as accurate as possible, make sure we're on the same page. We want to eliminate wasted time, doing that using the ClearCalcs load linking feature, using our quick member selector, using the material swap, and many other features to eliminate some wasted time. And then of course, available everywhere, whether you're at home, at the office, on site. I'm currently in Charlotte, North Carolina, at the Steel Conference. So if anybody here happens to be in Charlotte, definitely send that in the chat, because I'd love to be able to get a coffee, get a beer, just be able to meet you face to face. And then also with available everywhere, I was actually on a plane yesterday using ClearCalcs on the plane. So meeting the presenters, very sorry I don't have my camera on today, but I know I've met most of you, quote unquote, face to face virtually. I'm our director of customer success, so I'm here to make sure you're successful in ClearCalcs, whether that be through training sessions, through creating help content, anything like that. If you're joining today and I haven't met you, definitely send me an email, give me a ring. Always happy to chat. Want to make sure we're meeting all the members of our ClearCalcs community. And then in the background, helping me out with these technical difficulties, as always, is Addie, our head growth marketer. So she's here to make sure all our webinars, including this one, and super exciting, this isn't the only webinar this month. I think we have 3 or 4, and then even next month in May and moving forward, we'll start to have 1 a week, which is super awesome to see. And that's all due to the hard work done by Addie. So it looks like a few of you are already sending through your name, where you're tuning in from, your title, which is awesome to see. If you guys do have any questions throughout today's webinar, we're going to be running through a couple examples. So definitely send those through in the chat. We'll either handle those example by example, so make sure we're of course answering the example specific questions, or we'll have that 15 minutes at the end there that's dedicated Q&A. And then, so what we'll be talking about today, gonna take a quick swig of water and then continue. So if you guys signed up, you know that we are talking about beam design in the real world. And what we mean by beam design in the real world is we're going to take some real world designs. So for those of you that were at last month's structural basics on how to read structural drawings, we're going to take those same drawings. We're going to zoom in on a couple beam designs that are in that real world project, custom home built in Taos, New Mexico. And we're going to actually look at those beams in ClearCalcs. So the ClearCalcs calculators we will be focusing on are 2 wood beam presets, so the deck joist and the deck beam. And then also our wood connectors. That's kind of a little bonus. It doesn't have to, I guess it does have to do with beams, but it's not a beam calculator. I thought it was a good opportunity to show that. So we will definitely show how you can use that in our load linking feature. to design some Simpson strong tie hangers in ClearCalcs. And then in the second example, we'll just be looking at a generic steel beam. That one will be a bit less involved than that first example, but I think it'll be a great opportunity to really take information from drawings and show you where you put that into ClearCalcs. As I've already mentioned, and I know you guys could read, the ClearCalcs features we're going to be touching on are two different types of load linking. So one is going to be load linking a line load. So we're going to show you how to design that deck joist and then link that as a line load onto your deck beam. So we can design that deck beam in a snap, and then also load linking into that wood connections calculator. And then just fair warning, there's going to be a bit of back and forth today because I'm going to be jumping from the presentation to the drawings into ClearCalcs. So don't want to make anybody dizzy, but just an FYI, I'll be hopping back and forth quite a bit. So example one, we're going to be looking at deck components. Again, the reason I'm saying components here is because we're going to look at two different beam types and the wood connectors. So let me pop out of this presentation. Let's jump into our drawings here, which again, if you guys were at How to Read Structural Drawings last month, these should look familiar. If you didn't attend that, I highly encourage you to watch it if you need a quick refresher on how to read some structural drawings. But what I'm going to do here is I'm going to pop into our drawings, sheet number S02, and I'm going to zoom into what looks to be a beautiful outdoor deck here in Taos, New Mexico. We're going to focus on this deck joist J2 and this beam at the end here. Of course, there are many other beams, but we're going to keep it focused for our example here. So let's pop into this slideshow again, and we'll come down here into example 1A deck joist. So I took the time to just write in our given information, and I was specific here to the required inputs in ClearCalcs. So for all of our ClearCalcs users in here, you guys likely know when we're designing a beam in ClearCalcs, the required inputs are beam plan length, supports, loads, and then we're going to select our member. ClearCalcs is defaulting the rest of that information to conservative or per the code. But of course, we leave that to give you the flexibility to modify those inputs. So what I figured is we'll look at these givens and then I'll pop back into the drawings to show you how I know these are givens. Now, this first one, joist length, this is an assumption. So starting off hot here, I know, but per the drawings that I have, there just is no grid lines between the top and bottom of our J2 joist. So I just said, instead of trying to take the time of figuring out, let's go ahead and just assume it's 10 feet. Of course, if you guys actually get a set of drawings, you're going to know the exact length of that deck joist. But for the sake of example in this presentation, we're going to say that joist length is 10 feet. And then our support locations. So this is the second required input in ClearCalcs. Let's pop out here. And we could see from our drawings, if we're looking at this J2, and I'll even use my screen drawing tool that I'm hoping we're seeing, we're just simply supported here. Every one of these joists in this joist system is starting at 0 and ending at 10. So we know we got a support at 0 and 10, which when we pop into ClearCalcs, we'll see that it's already going to default to that, and it's going to be pretty easy. That been correct. Yeah, we can scale the drawings and then measure that dimension, whether we're using, I know in my former job as a consultant, used Bluebeam a lot. So that might be something you guys are using. Definitely something that you guys could, or the engineer could figure out that joist length. Whoops, scroll down there. Next is our bearing lengths. So as you guys know, if you're a ClearCalcs user or a ClearCalcs trialist, or if you've just seen a ClearCalcs calculator at all, you know, we're also looking at bearing when we're doing our wood beam calculations. I'll give a quick caveat here that determining the actual bearing length, what I'm quickly going to show, takes a bit of time. I'm sure a lot of you know maybe, hey, bearing's not gonna govern. I can just put in 3 inches, a conservative estimate, and I'm good to go. I just want to snap my finger, get done with my beam calc in a minute. For the sake of completeness of this example, I'm actually going to look at what our bearing lengths actually are. So again, where did I get 6.5 inches from? Let's go ahead and pop out here. So we have support 1 of our joist system. I said was this top beam. We're looking at our top beam. And to determine the actual connection to that top beam, again, calling back on our how to read structural drawings, it's telling us to look at sheet S3.3 detail 7. Whoops. So let's go ahead and look at that to see what that actual connection looks like. Scroll down one more. Let's go ahead and zoom in. So we see we're at sheet S3.3, detail 7, deck joist to beam. And we see that we've got our joist coming in here horizontally, bearing directly on this deck beam that we're gonna go ahead and design in the second part of this example. Now we see that we actually have 2 rim joists at the end here that make it so our joist isn't bearing completely on our beam, but instead there's some width being taken up by our rim joist. Now, let's go ahead and assume that our rim joist most likely is just the same selection as our actual joist here. So the reason I'm saying that is because we need to figure out what width our rim joists are taking up to determine the actual bearing that's on our joist. To do that, I'll show you really quick what that J2 selection was. So I'm going to come back to my S02 and I could scroll into my floor joist schedule. If my scrolling pad works, here we go. J2 was a 2x10 at 16 inches on center. So we can assume that those rim joists are 2 2x10s back to back because it's telling us that there's 2 rim joists. Now, because we all like to be confusing here, a 2x10 we know actually isn't 2x10. That width, instead of being 2 inches, is 1.5 inches.
Did you see that fucking example?
We'll go ahead and scroll down to S3.3.
I'm looking at it right now.
And instead of 2 inches, like I mentioned, it's actually 1.5, as we know. So if we have 2 times that, 1.5 plus 1.5 is that 3 inches. So we can say we've got 3 inches of width here being taken up by our rim joists. And that width just depends on how many rib joists we might have. And now we just need to determine the width of this beam here. So remember, we have 3 inches, and I know this feels like a lot of work just to get this bearing, and that's why I mentioned, I'm sure a lot of you just kind of already know bearing might not be governing, and you're going to put in a conservative value, but for the sake of completeness, again, we're gonna determine it. So beam per plan. So basically, we know we need to find the dimensions of the beam per plan and subtract that 3 inches. Let's zoom in. It's telling us this beam. Oh, I'm getting a lot of comments that it isn't 2 rim joists. Very sorry about that. I'll just go ahead and say it's just 1 rim joist, just so I'm making sure to do the correct thing here. I appreciate the comments. So we'll say 1.5. 1.5 there. So our beam 5, our deck beam is beam 5. We see that's a big old thick 10 by 18. And again, 10 by 18 isn't actually 10 by 18, that 10 is 9.5. So if we come back here, and per our engineer's comments here in the chat, thanks a ton, we actually don't have 2 times the rim joist. There's actually only 1, so it should be 1.5. We've got this 10 by 18 minus 1.5. So 9.5 minus 1.5 will give us 8 inches. Let's pop back out here. We'll change this to 8. Oh, and I was incorrect with the 9.5. It looks like Google led me wrong. So we'll go ahead and do 7.75. Looks like Google led me astray there. So very sorry. This is an interactive demo. So we'll go ahead and do 7.75 there. And aside from the comments there with there's 1 rim joist and then the 9.25, are there any questions on how that was determined? It seems like everybody was following along pretty well. I'll just hold on for a second here, just in case. But it seems like we're following along. This next one here, that 1.75, let's hop back into these drawings. Oh, looks like there was a question above regarding clear span. In ClearCalcs, is beam length clear span or out to out, including bearing length? So in ClearCalcs, it is center point to center point. So I can go ahead and send to everyone per Alex's question. ClearCalcs is center to center. Thanks, Brian, for reminding me about that one. All right. So what we're doing, we found our 7.75 now inch bearing length. But what we're going to do is find the actual controlling one. And I'm going to make an assumption here for the sake of showing you something that ClearCalcs can do. So what we did, we found the bearing length on the top. And now we want to find the bearing length on the bottom of our joist. To do this, I'm going to go back to my joist. And again, like I mentioned, I'm going to make an assumption here. For RJ2, we say we're this 2 by 10, 16 inch on center. And we say we're this Simpson strong tie hanger. Now, for the sake of highlighting the wood connections calculator and showing you another way we can determine this bearing length, what I'm going to assume is that, let me scroll out here. This beam at the bottom, or the connection between our joist and this beam at the bottom, is our joist on the hanger, actually. So we're going to assume at the bottom, it's not bearing on top, but it's going into the hanger. Now, to determine that hanger's width, what we can do is come into ClearCalcs, actually. Another way, of course, you can look at the catalogs and get the dimensions. So let's go ahead and log into ClearCalcs. And I'm going to hop into a project that I had already started here. And what I'm going to do is show you how this 1.75 is coming from the Simpson strong tie hanger that was specified. To do this, I'm going to add new calculation. And once this pops up with my, again, technical difficulties here, what we're going to do is click on the wood connections calculator, wood connectors. And we're gonna go ahead and pop into the selection. Again, we're not actually designing these yet, but all I wanna do is look at the dimensions here. I'm gonna click select. I'm gonna pop out into my drawings so I can double check what my hanger was. And I'm gonna look this up in ClearCalcs. Bless you. All right. So we can see at the top, we've got this 2x10. As we spoke at the beginning, our joist was a 2x10 selection. So this is likely what's being spec'd. And we could see our width here is 1.75. So that's where I got the 1.75 in this gibbon. So we'll go ahead and do these loads, or the next gibbon. Sorry, I lost my train of thought there for a second. I love Vicus's laughing emoji there. Finally, we'll just look at where we got the loads. This will be a quick one. As I'm sure you all know, in the drawings, we're going to go to the top. We're going to see our loads here. We're going to see the code that we're using, IBC 2015 with New Mexico revisions. And then we're looking at live load, dead loads, and then snow loads. For the sake of simplicity, I just used this 40 PSF as the roof snow load. So we had a dead load of 20, snow load of 40, the minimum deck live load per the code of 60, which we'll see in ClearCalcs. And then we know our tributary width is 16 because again, we had a 2x10s at 16 inches on center. Now, after looking at all of that, let's just hop into ClearCalcs and punch in these numbers. So I'm going to add new calc. I want to do a wood beam. Doesn't matter LRFD or ASD from the user's standpoint, but most of the users are using ASD for wood, so I'm going to use that. Let's open up our deck joist preset. We'll call this J2 deck joist because that's what it's referred to in the drawings. We know our beam plan length is 10 feet. We assumed, or we found out via Bluebeam by scaling the drawings. So it's already at 10 feet. If we want to change it, maybe it happened to be 12. This is where we do it. But we got lucky that it's already at 10. We know our now correct bearing lengths of 7.75 and 1.75. Appreciate everybody for their input there. .75 and 1.75. Now let's scroll down into our loads. Like I mentioned before, let's expand this minimum balcony / deck live load. We can see that with the exception of the IRC, the minimum deck loads are taken as 60 PSF, and the CR, or the California building code, sorry, also amends the IRC to have 60 PSF deck load. So ClearCalcs deck preset is already pulling that in. And it looks like all we have to do is modify our dead load to be this 20. And then let's just add this snow load, just for conservative sake. I know some people might just include that in the live load, some might not. Just in talking with a lot of our users, let's go ahead and add it. Let's double check center to center spacing, 16 inches. We're good to go there. Now let's just select our member. So we already were on a 2x10 dug for large number 1. We'll go ahead and select if we wanted to change that. 2x10, maybe we wanted a number 2. Let's go ahead and filter this. Now we're seeing all 2x10 number 2s back to back here in ClearCalcs. So I'll just go ahead and swap here to this 2x10 dug for large number 2, just to show you how that's swapped. So I know a lot of back and forth there with the drawings. I'm sure you guys unfortunately deal with that day to day with going back and forth between Bluebeam and either ClearCalcs or Excel or whatever you're currently using. But that's how, with the input of the engineers, we'd find these bearing lengths, right? And then the rest of these inputs from the drawings. With the next beam design in our webinar here, I'm going to look directly at that deck beam that was at the top of our deck system. Let's go back into our drawings here just so I can show you. And we'll just do this in a minute. So we'll scroll up. Here's the beam we want to design, this beam at the top, which our joists are bearing onto, like we already looked at. So deck joist length is 24 feet. I'll spare you guys me swapping back and forth, and I'll just promise that it's actually 24 feet in the drawings. We saw we were simply supported. We saw that I need to change this to 9.25. And that 9.25 comes from the 10x10 posts that we're bearing onto. So appreciate Ari, that input. And then if I find my cursor here, and then our loads, we don't even need to worry about that because we're going to go ahead and link those as the line load onto our deck beam. Don't need to leave there. I could just stay here in Chrome. Let's add a new calc, wood beam. This time we want deck beam. And I believe per our drawings, yep, that was beam 5. So beam 5, deck beam. As you guys can see, by default, ClearCalcs is telling you a deck beam is going to be 3 plies. You might have that in some cases. In our specific case, we only have that 1 ply 10x18, if you recall. So I'm going to bump that back to 1. We see we fail pretty miserably, but we're only at a 2x12. So when it comes time to select, we'll be a bit more accurate there. Beam plan length was 24. These bearing lengths were 9.25. And then our loads again, we don't need to worry about them because we're going to link. And the reason we're going to link it as a line load is because we're linking this deck joist to our deck beam. So what I did there, I had a drop down of all the linkable joists. These are my practice ones from last night. So this is the one we just did. And then we'll go ahead and click 0 because it's location 0. Finally, we just need to say horizontally along our deck beam, where does our deck joist link in? Where does it bear onto? So we could see from our drawings that that joist is going the entire length of our beam. It's not starting halfway in, it's not ending a foot early, it's just going the whole way with the beam. So we could say 0 to capital L. And now we've got that deck joist linked down here. Now we'll come in select. Let's select that 10x18. And let's just go ahead and say we want a number 1 again, or not again, but I'll say it for the first time. My reason for saying number 1 instead of number 2 the first time is just to show you how you can use different filters. You might be using the same grade of a wood in your project, but I'm just kind of switching it up here. So let's just choose this 10x18 dug for large number 1. And here's where anytime we might change something in this deck joist calculation, it will automatically update in the deck beam. Really quick, like I mentioned, just kind of as a bonus, I want to hop into this wood connector and show you very quick. I know it's unrelated to a beam, it's not a beam calculator, but we can come in here and link our deck joist at location 2 to this calculator. And then we can come in here and actually select the hanger that's going to work. It's going to tell us what passes, what fails, as you guys are familiar with seeing in ClearCalcs, the green, yellow, red. So we could go ahead and actually select this 2x10 hanger. I'm going to pop back here into our presentation. Again, make sure you're sending any questions through, or feel free to unmute yourself. Caleb, be careful unmuting yourself. Just joking there. And we'll go ahead and hop through to just the last very simple beam design calculation here. So the example that we're going to do here is just a straightforward steel girder. The only kind of, I guess, nuance, for lack of a better term, can't think of a better term, is when we look at the tributary width and, of course, that input into ClearCalcs. So I'll pop back into our drawings. And the steel girder we're looking at here is labeled. So it's just one big old beam that's going kind of the length of whatever room this happens to be. Now let's pop out. Again, to save you from popping, or from me popping back and forth, the steel girder length is 28 feet. Supports, we're going to say we're simply supported at 0 and 28. For this specific case, and this is probably one of the only differences between the steel calculator and the wood beam calculator in ClearCalcs, is the bearing lengths. Because the steel calculator isn't doing bearing checks, because it rarely, if ever, governs, we don't need to look at that. We don't need to input that. And then the loads here. So again, I gathered these loads. Let's pop back out. Just so you know, I didn't make those up out of thin air. A few questions. Oh, yes, with wind. So I should have made it clear at the beginning. I was just focusing on the gravity loads just for the sake of simplicity in today's example. What I can do, actually, I think this will be a good piece of help content, is kind of do that example over, but then include wind in there. So that way we can have that help content and make sure to send it out to everybody. Thanks for sending that through. Looks like Jason and then Lee. So thanks for sending those through. Just focusing on gravity today, but I'll make a note to create that help content in the very near future to send that out. All right, so back to this one, this tributary width. 14 feet. I'm assuming I'm going to have some questions on this. Let me pop back into my drawings. And like we said before, we can get the actual dimensions here using Bluebeam, or actually just using the sorry, I'm looking at the chat here. Sounds good, Lee. Sounds good, Kathleen. Yeah, we'll definitely make sure to send out an example with wind. I agree. I get that question a lot on the training sessions I'm in as well. Oh, and then it looks like another question here from Nabeen. Sorry, I missed this. So when you link that joist to the deck beam, will the software automatically link the joist beam spacing 16 inches? Yes. So when we're linking it as a line load, we are taking into account, we're essentially estimating it as a line load using that 16 inches on center tributary width. So you'll see if you modify the center to center spacing in your deck joist calculator, maybe to 18 inches, just making up a number, then you'll see that deck beam that it's linked to is going to automatically recalculate because it's going to be a different PLF that's coming down. But that is a great question. Thank you. All right, great questions. All right, where was I? Popping back into the steel girder, we were talking about tributary widths. So we can figure out the exact dimensions. I basically made some assumption dimensions, and I just assumed to the right-hand side of our steel girder to the next wall was 20 feet. Hope you guys can see my drawing tool. And then to the left-hand side was 8 feet. So when we were looking at the tributary width, half the distance to this side, 10, half the distance to this side, 4, because again, I said that was 8 feet. So total of 14 feet. And because I think this question is coming, so ClearCalcs, as other similar design software, we're not taking into account that torsional effect of the uneven loading because it rarely governs in the residential and light commercial design. So you would input it just like it's that 14 feet. And I'll show you how you input it here. Let me know if you guys have any additional questions in the chat. But just, I get that question quite a bit on demo, so figured I'd point that out. So I'm going to add new calc. For steel, I'm just going to open the LRFD. Completely up to you if you use ASD or LRFD. It's the same interface, but I just see users using LRFD much more often with steel, so I'm going to open that. We'll just say this is steel beam. What do they call it? Just beam 1. Nice and simple. And let's go ahead and input our values here. So we had 28 feet and simply supported. The yield strength I can change if I want to, but this is defaulting to the typical yield strength of the cross section that we select. So I'm just going to leave that. We could override that if we want. For continuous bracing, ClearCalcs is going to default that for the generic beam at no continuous bracing to be conservative. If this is a floor girder, we're probably top brace, maybe even top and bottom brace, depending. So I'll just change that to top, but it would be conservative to leave it at no continuous. We'll go 0 and L because we're simply supported. And then let's go down to our loads. So if we recall, our loads were floor dead load of 20 and floor live load of 40 with a tributary width of 14. So we had our floor load with a full length, tributary width of 14. And then we only had a dead load of 20 and a live load of 40. Let me double check to make sure that isn't the perfect. All right. And then per the drawings, I'll say at the time of popping back and forth, it said that we wanted a W12 by 45. So that was the selection. So we can see we're already here with the 12 by 45, with the governing being our critical deflection at 82%. If we didn't get lucky and it was already at the W12 by 45, we can come into select. Maybe we only want to see those wide flange beams. And maybe we want nothing bigger than a 12 by 12 cross section. Now we can start to see what passes, what fails within those parameters. So I'll go ahead and exit out there. So for today, like I mentioned, I was just trying to keep it relatively simple and show how we can pull information from drawings, put it into ClearCalcs. Thank you guys a ton for the feedback on the wind. That is a piece of help content we're definitely going to create. I'd say wind, and then some people I'm sure have questions on potentially seismic as well, or just lateral in general. A few things I want to point out before we hop into the questions, just this what's new. A lot of you guys, or hopefully all you guys, got the email recently on what's new in ClearCalcs. But if you didn't, the IBC 2021 fully up to date now in ClearCalcs, thanks to our engineering team's great work. All our concrete calculators are up to ACI 31819. So that also means California Building Code 2022, we're all set there, because the only thing we were waiting on were those concrete updates. So all up to date. And then also what the engineering teams recently added within the past few days was the Florida Building Code 2020. So how do we get those? In ClearCalcs, you'll go to project defaults. And then at the top left here, you see design code for load combinations, drop down. If I scroll all the way to the top, you can select IBC 2020, 2021, all the way back to 2009, IRC, California Building Code, as well as Florida Building Code. So, and then you could also go custom as well. So let's pop back in here. All right, and then I'll just kind of open the floor to questions. I know I've had some great questions. Monisha, just wondering if we had previous upcoming webinars for truss. That's a very timely question, because Addie, correct me if I'm wrong, I believe the truss webinar is next week.
Yes, the same day, the same time next week.
Same bat time, same bat channel next week. I believe Laurent will be running that. Yeah, Joe, thanks for sending that chat. So you guys should be receiving an email. If they haven't gotten any emails or anything like that to sign up, Addie, where would they be able to find? Or I guess I'm sharing my screen, I could show them.
Yep, and I'm going to pop the link in the chat as well.
Thanks a ton, Addie. So what I'm gonna do is just come to clearcalcs.com. I can click learn from that home page, and there I could see upcoming or past webinars, videos like help content, support articles, case studies, all that fun stuff. Let's see, Mandy, do we always use pinned in ClearCalcs? Great question. So we default them to pinned in ClearCalcs. So let's pop back in here. Let's do a steel beam. The support types will always be defaulted to pinned, but you have the option to come in here and say fixed, pinned, roller, hinge, or braces, if you do have different support types there. Hopefully that answers that question. Vikas, hopefully I'm pronouncing your name correctly. When are we updating the connection details for Canada? So hopefully that's coming soon. To be honest, so the focus for the near future is truss design, which I think the team just recently released a version 1 of advanced wind, so MWFRS, which we're close to finishing. So I'm not sure if it's going to be a near-term thing, but it's definitely something that we're going to be adding. Actually, if you don't mind, send an email to help@clearcalcs.com just with some extra info on the types of connections you're looking for, like what the top priority would be there for you. So that way we can get that added to the engineering team's list and we can continue knocking that off. All right. I'm looking at the questions here. Dave, yes, great point. So really my alluding there was, I've been on some demos where I've heard people say that. You're very correct though. We want to make sure to differentiate, especially with the load combinations, which we can see here. So maybe 1.2 dead plus 1.6L plus 0.5S. It's being differentiated between there. So because the code differentiates it, definitely make sure you differentiate that. Brian, so you noticed we only had ASD in the wood connections module. So he's asking, does it matter if we're designing members in LRFD, but using ASD in connections, using links? That is a great question. I don't believe you're going to see any issues on our end. Let's actually just test it live. And if we see an issue, then yes, there is an issue. But let's go ahead and check this out. So maybe deck choice and wood beam, or modify this. Oops. To LRFD, if I can type. Oops. US wood connections. Thanks, Joe. I'm glad you're able to join. Hopefully you have a great rest of your day. All right, so from ClearCalcs perspective, yep, we are not able to link the LRFD into the ASD. So that was a great question there, and glad we were able to kind of look at that real time. Looks like the LRFD can't be brought in with the ASD. All right. So Kathleen, inputting concentrated lateral loads from shear wall hold downs. Great question, Kathleen. That might be something that I'm going to need some engineer or one of our engineers' assistance on. So let me copy paste this. I'm going to put it into my notes so that way I can connect with the engineers very soon and get you an answer on that one. So the two we're looking at is inputting concentrated lateral loads, and then of course, the wind examples, because I know that one came up a lot. All right. Great to see some conversation going on in the chat. We do have about 10 more minutes or so, so keep those questions coming. As you've seen, if for some reason I don't know the answer, I'll definitely chat with our engineering team. All right. All right. Well, oh, perfect. That's a great great chat there, David. Addie and I were actually just discussing sending out certificates and emails so that way you guys can get some hours. So we will make sure to do that. Thanks for sending that through. If we want a webinar according to our doubts. Yeah, I'm happy to chat. I'm curious to hear what you have to say, Vikas. So what I do, I don't believe we've met before, but I'll run training session, Q&A, anything like that, whether it be before or after you're using ClearCalcs. So I'm more than happy to connect and talk through any questions that you might have. Might have to be next week, just because like I mentioned, I'm at the Steel conference this week, so time's a bit tight, but I'm more than happy to connect with anyone. Do you ever use auto size? Good question, Bruce. Really, that's just up to your preference as a user. So, oh, it looks like you asked Jason. So Jason never uses it. I've talked to quite a few people who do use it. It really just depends on how you think your timing might go a bit quicker. If you do auto size, what you'll need to do, if you see my screen still, you'll need to add preferred sections. What these are your favorites. And then when you're in the calculator and you click auto size, what that's going to do is just automatically calculate the most optimal section of your preferred sections. But like Jason mentioned, we do have a few power users who don't use it and just use this select button using these filters. See in real time what passes, what fails. Really up to you. Good question though. Yes, Lee, looks like Addie was able to send a response there. So all webinars, you can follow that link on clearcalcs.com/videos, webinars and other help content that we're creating. All right. Well, I'll make sure if you guys have a place to go ahead. I'm done with my end. If anybody has any more questions, I'll definitely make sure to hang out for a few more minutes here. If some stragglers come through, we do have about 7 more minutes. Otherwise, I really appreciate your guys' time. Thanks for working with my technical difficulties and allowing me to have my camera off. Thank you, Brian and Shane. Is it possible to flip the order of member sizes in selection table? Good question. Possible? Yes. Let me chat with our developers to see what we can do there. Right now, it's just, as you see, in order of size with your selection at the top. In the meantime, what I'd suggest is you use these filters here, max width, max depth, because I think that'll help save a ton of time. All right. Thank you all. Thank you all. Appreciate the thanks. If you guys have any questions, then go ahead, send them to help@clearcalcs.com. Hopefully you guys have realized by now it's not just any help email where it just kind of gets lost. We actually have a structural engineer on support duty every day. I get those as well. So please send your questions there and we'll make sure to connect. Oh, last question from Dave. Thank you. So can we confirm there's no way to adjust the duration factor by the user? Okay. So the duration factor, if I scroll down here, we can change, or whoops. That might be something I need to connect with the engineering team on. I believe it has something to do with changing impact occupancy storage. It's a very timely question because I had a demo yesterday with our North American structural lead. Laurent was there too, and he was talking about duration factors. So I might reach out to you, Dave, and have some more questions there. And then Kathleen, is it possible to set the species to default? We only use Southern Pine, but I have to scroll through the others. Great question. Right now, the way I'd suggest you do that is setting those preferred sections to the Southern Pine. And the nice thing there is if you just take the time to set them once, then you could just copy from another project. And then when you do create your preferred sections, those will always be at the top of your member selector. And they'll be starred. So I can show you how to do that really quick. Let's just go ahead. I'm going to click on a few random ones. Of course, you can filter this down to Southern Pine. I clicked these random 2x3s. So now when I come into the member selector, those 2x3s are going to be brought up to the top starred. So that's how I'd suggest you do it right now, Kathleen. All right. Well, if that's all for the day, again, thank you, everybody. Send those questions to help@ClearCalcs. Send questions, suggestions. Let us know how we did on this webinar, other than messing up a few dimensions, if we could be better, and definitely send through any suggestions on webinar topics, because we're always looking. So enjoy the rest of your day. And if anybody's in Charlotte, please let me know if you're at the Steel Conference. Would love to be able to connect. Oh, Jason, it looks like it looks like you had a CR question. If feel free to email me, Jason. I'll go ahead and shoot you an email right now. where we can kind of go back and forth and I can get your questions and comments there. Really appreciate it, everybody. Enjoy the rest of your day.